Tech giants like NASA and Google have made serious breakthroughs in flood forecasting, and that matters, because floods are still among the deadliest natural disasters on Earth. Every year, they destroy homes, displace families, and take countless lives. But here's the big question. Can flood prediction models actually save us?
That's a powerful question, Silvia, and one that's more relevant now than ever. You're absolutely right. From the Himalayas to sub-Saharan Africa, we're seeing the same tragic patterns repeat, and it taps into a common misconception that flood forecasts are so unreliable they're useless. But the truth is, while they're not perfect, they've already saved thousands of lives. The problem is how we use them, not whether they work.
In Bangladesh, that fear comes back in every monsoon season. In the low-lying deltas, families rebuild homes 3, 4, even 5 times, only to watch them wash away again. The rivers rise fast with heavy rain upstream, and warnings come late, or not at all. Children climb trees to escape the water. Cattle drown. The same nightmare plays out in India's Brahmaputra Basin, the Terai Plains of Nepal, Pakistan's Sindh province, and Nigeria's Benue Valley. It's heartbreaking and frustrating.
These are not isolated tragedies, but regular events in large parts of the developing world where floods displace millions each year. In 2022, Pakistan's floods alone affected over 33 million people, killing more than 1,700. In Bangladesh, over 60% of the country can be submerged during peak monsoon years. Yet the technology to predict such disasters in advance, flood modeling and forecasting, is either limited, unreliable, or not deployed widely enough. Investment in dense gauge networks, real-time hydrological data, and advanced modeling tools remains scarce.
It might be tempting to write this off as a problem of poverty, but here's the paradox. Even in wealthy, technologically advanced nations, floods remain alarmingly unpredictable. And when they hit, like they did in Central Texas in July 2025, or in Western Germany in 2021, or Kentucky in 2022, the damage is immense. Roads are ripped away, homes washed clean off their foundations, and lives lost. In the US, despite a suite of modeling tools from NOAA, the US Geological Survey, and countless academic institutions, floods still kill hundreds and cause billions in damage each year. So what is the use of flood prediction modeling then?
It's a valid question. If the richest countries, armed with satellites, machine learning algorithms, supercomputers, and networks of rain and river gauges, still struggle to forecast a deadly flood 24 hours in advance, what hope is there for the rest of the world? The answer lies not in whether flood modeling works, but in how it's being used and what its limitations really are. Flood prediction is not a magic solution. It is a tool, highly effective under certain conditions and largely inadequate in others. And another common mistake? Assuming we can predict exactly when and where a flood will hit. Forecasting is about probability, not certainty. It buys time, but it can't eliminate risk.
What are you getting at, Ryan? Why are these models still falling short?
It comes down to the type of flood we're dealing with. In large river basins, like the Mississippi in the US or the Ganges in South Asia, floods tend to unfold slowly. The water takes days to move downstream. That gives models time to analyze, simulate, and provide 3 to 7 days of warning. And that's impressive. It gives communities a chance to evacuate, fortify infrastructure, and save lives. But it's a completely different story with flash floods, like the one that struck Texas Hill Country in July 2025, killing over 100 people. These floods hit within minutes to a few hours, often at night, and are triggered by localized, intense rainfall. Even the best radar systems can miss them. And traditional models, built on historical data, simply can't keep up.
And here's where the real tension lies. We've seen huge breakthroughs in flood modeling. In the last decade alone, machine learning-based systems from Google have expanded across South Asia and Africa, predicting riverine floods up to a week in advance. They even send out real-time alerts via smartphones, reaching millions of people. That's incredible. Those alerts are powered by the Flood Hub platform. It delivers easy-to-read flood maps and daily forecasts for over 100 countries, reaching a global population of 700 million people, all for free and all accessible from a smartphone. But then you look at the headlines, the casualties, the damage, the repetition of disaster, and you can't help but feel, has anything really changed? Is flood forecasting truly working where it matters most?
You're right to ask that, Silvia. From NASA's satellite-powered SERVIR to Google's AI-driven systems, flood forecasting have made a lot of progress. But there's also this idea that with enough tech, AI, satellites, cloud computing, we should be able to predict every flood. That's just not true. Even the most advanced models need strong local input data, real-time rainfall, river levels, even ground saturation. Without that, even the smartest algorithms struggle.
Ryan, you have just talked about SERVIR. Could you tell me about it? How did the initiative come about?
SERVIR was launched back in 2005 as a joint effort between NASA and USAID. The goal was to harness satellite technology to help vulnerable regions, especially in the developing world, better monitor environmental hazards like floods. Before SERVIR, many countries lacked access to reliable, real-time data on their rivers and rainfall. SERVIR changed that by providing satellite imagery combined with climate and hydrological data to local governments and agencies. It helped build the foundation for flood prediction models in places where traditional infrastructure was limited or missing.
So, SERVIR was about making space-based data practical and accessible on the ground.
Exactly. It wasn't just about sending data. It was about training local scientists and decision-makers to use it effectively. Over time, these models grew more sophisticated, combining satellite inputs with ground-based measurements and weather forecasts to predict floods days in advance. SERVIR uses NASA satellites to monitor rainfall in river systems across entire regions, but it becomes much more powerful when combined with local ground data, like rain and stream gauges. That hybrid approach helps make the forecasts more relevant at the community level. But as time went on, scientists and engineers realized that traditional models had limits. They relied heavily on historical patterns and physics-based simulations, which struggled to keep up with rapidly changing weather extremes driven by climate change.
Is that when AI started to come into the picture?
Yes. Over the past decade, artificial intelligence and machine learning began transforming flood forecasting. AI models can analyze massive datasets faster and often more accurately than traditional models. Everything from satellite images to radar scans, real-time rainfall, river levels, and weather patterns. One of the earliest uses of AI in flood forecasting was to improve short-term rainfall predictions and generate probabilistic flood warnings. This helped expand coverage to regions that were previously hard to monitor, like remote parts of South Asia and Africa.
So even AI-powered systems still depend on good input data, like local rainfall, river flows, and radar scans.
They do. AI models learn from the past, so the better the historical and real-time data, the better the forecasts. That's why improving local sensor networks and data sharing is still a major priority.
And that set the stage for something like GraphCast.
Exactly. GraphCast, developed by Google DeepMind, represents the latest leap in this evolution. It's a deep learning model designed to forecast weather globally up to 10 days in advance, using a graph-based neural network that captures complex atmospheric interactions better than ever before. While it's primarily a weather model, GraphCast's detailed and fast predictions of rainfall and storms feed directly into flood forecasting systems worldwide. Its speed and accuracy open new possibilities for earlier and more reliable flood warnings on a global scale.
But just to be clear, GraphCast itself doesn't predict floods.
Right. It forecasts weather, especially rainfall, at an incredibly high level of accuracy. Those rainfall predictions are then used by hydrological models to estimate flood risk, so it plays a critical upstream role in the forecasting chain. Google's flood forecasting system is built on two interconnected AI models: a hydrologic model that forecasts river water levels, and an inundation model that maps where floodwaters will spread and how deep they'll go. With these tools, the Flood Hub platform now provides daily forecasts for over 100 countries, reaching 700 million people worldwide. It empowers communities, aid workers, and governments to act before disaster strikes.
So from SERVIR's satellite-powered early days to AI-enhanced predictions, and now to GraphCast's cutting-edge forecasting, flood models have come a long way.
They have. But each step has built on the last. Satellite data enabled global monitoring, AI brought speed and pattern recognition, and now models like GraphCast are pushing the boundaries of what's possible, helping us prepare better for floods before they happen. And yet, even with breakthroughs like GraphCast, we have to face a tough reality. Some floods, especially flash floods, will always be incredibly hard to predict.
Because flash floods don't give us time. They form fast, often from isolated storms, and can overwhelm communities in a matter of minutes.
Exactly. No matter how advanced the model, there are physical limits to how quickly we can observe, interpret, and alert. That doesn't mean the systems are broken. It means we're up against the raw speed and chaos of nature. When used well, especially for slower river-based floods, these models have saved thousands of lives. They give communities precious hours or days to prepare, evacuate, and act. And some people argue flood forecasting isn't worth the cost. But that's another myth. Even a few hours of warning can prevent catastrophic loss, and the returns in saved lives and avoided damage far outweigh the investment.
Technology can't stop floods. Flood prediction models are tools, not guarantees, but it can give us a fighting chance.
And in a world where climate extremes are only getting worse, that chance may be the difference between tragedy and survival. And it's also worth saying, floods don't just hit where we expect them. A lot of people still think flooding only happens in monsoon zones or known danger areas. But even drought-hit regions can flood suddenly, especially with extreme weather events becoming more frequent.